Looking ahead to 2012, a lot of changes are expected in how Internet identity works. Today we're going to cover 4 different areas. The first is some work to greatly simplify the user experience for signing in and signing up on the web. That's referred to as the account chooser. The second is some specific technology that's used to avoid the problem with people reusing passwords across websites. The third is to give users the choice for how they can share their verified and trustworthy identities, such as their street address and name, with a website. And the fourth is to talk about how we would more strongly authenticate users for the one or the smaller numbers of passwords they would have on the internet. So let's start with a common scenario. A user is logged into their computer, in this case Bonnie logged into her email account, and she comes across a website that she's never used before, in this case User ID TV. She wants to go online and watch some online premium video content. And so she sees the standard sign-in button, no surprise, just clicks that. And normally she would then expect to see one of those painful sign-up flows or have to try to remember if she has an account. Instead, what she'll see in the future is something we call the account chooser. Her browser will keep a list of the commonly used accounts that she uses, or potentially other people on that computer use, for example, if she shares the computer with her husband, Clyde. So after Bonnie has clicked sign in, she simply clicks the account she wants to use, maybe the top account for her personal account, or the one in the middle for her work account. In this case, let's assume she just clicks the top one for her personal account. She'll now see a page that many of you are probably used to seeing these days, where she's asked to consent to sharing some information with this other website. Google is showing this page because she's logged into a Google account, but it could have been any relationship manager that she wants to use. So the site asks for information like viewing her email address, basic information about her account, etc. She clicks allow, and boom, she's logged into the site, and now the site recognizes who she is. Very simple process. So that is the account chooser. If you want to learn more about it, there's a website, accountchooser.com, that you can go to. And there is a working group in the OpenID Foundation to focus on the specifics of it. If you're a technical geek, then you might be interested to know that this isn't specific to particular protocols like OpenID or OAuth or SAML. It's designed to be a generic scheme that will work for any protocol to help users more easily sign in and sign up to websites. And while we said that this list is kept in the user's browser, it doesn't actually require extensions or changes to the browser itself. It relies on a central HTML5 application running on the browser. And in fact, there are already some products today that integrate this feature, and so websites can use those products to start rolling this out to replace their traditional login box. In fact, even Google is starting to work on replacing its own login box with this approach. And if you want to try it out today, just do a Google web search for account chooser experiment, and there's a page that will tell you how you could turn it on. Now, another thing to notice is when the user is on this consent page, there's this little word up here that says OAuth 2. OAuth is becoming the lingua franca for internet identity standards for many different use cases, for logging on, for sharing information between websites, for connecting mobile applications to websites. IT managers who are dealing with the cloud have consistently told big vendors like Google, Microsoft, Facebook, etc., that they need standards for internet identity. They can't deal with 5 different approaches and trying to fit them all together. So the major vendors have shared best practices and developed a technology called OAuth, and more particularly the second version, OAuth 2, to be a single technology that can support many different usage scenarios, including this one of enabling user to log into a website without needing another password. If you're an IT person who wants to learn more about the protocols, you can visit oauth.net and read up on OAuth 2 in particular. But as I said, the key thing to take away is there's this one technology that we suggest that you use for identity in the cloud. We recognize that still there's a lot of technology not on the cloud, on-premise systems, for example, and they'll use other technologies, but OAuth is designed for the cloud. It's very focused on web services standards like REST and JSON. Now, another term that you'll hear is OpenIDConnect. OpenID is traditionally associated with the idea of being able to log into a website without needing to create a new account. We as a community have re-implemented the functionality of OpenID on top of OAuth 2. We refer to that as OpenIDConnect, but at the end of the day, it really is just OAuth 2. So that's the second big piece coming in 2012. Now, the next thing is, great, okay, a user doesn't need to, create new accounts to sign in or sign up to websites. But there's that old joke that no one on the internet knows whether you're a dog or not. So how do you prove you're not a dog? What if you get to a website and you want to perform some serious business? You want them to know you're verified, for example, street address. Maybe you're trying to access your medical records online, your social security records, tax records, utility records, or maybe you're a subscriber at home to some premium TV channel and you want to be able to visit that TV channel's website on the internet and watch the content there. So now we're going to talk about how that might happen. In some of the examples we showed before, the user logged into this website, user ID TV, and wanted to watch some premium content. Now, the user is logged in here, but this website is telling the user that, hey, okay, I know you're Bonnie Parker at gmail.com, and yes, you're logged in, but I have no idea if you're a paying subscriber to my premium TV channel. So it tells the user that, hey, they need to verify their subscription status, and it asks the user to pick their address so that this website can go and talk to the cable providers in that area to find out if they're a paying subscriber. So, the user picks that one, and you'll notice, before the question was, how did this website get the user's address at all? Well, before, when the user gave consent to log into this website, they were asked to share their email and information about their account, but they were also asked to share their verified street address. So that's how this website actually, got that list that we showed previously. So if the user goes ahead and says, yes, please use that address for the subscription, the website can go get their verified address, use that to look up their subscription status, voila. In this case, the website did verify, who they are in a trustworthy manner, was able to determine they're a paying subscriber. Great, now they can watch this premium video content. So for the end user, that's a great experience. Go to the website, click sign in, click your picture, agree to share some information, including your street address, and boom, you can access, premium content online or tax records, health records, etc. But while this has been a goal for the industry for a long time, there's a lot of hard things we have to do behind the scenes. And we're going to talk through a couple of them here, starting off with the question of, okay, how did the user's street address get verified in the first place? The way that this is done is by introducing the concept of an attribute provider. This is a company who can verify a piece of information about a user, their age, their date of birth, their gender, their street address, whether they are a Stanford University graduate, etc. Lots of different attributes. So an attribute provider can verify a piece of information about a user either because they've already verified it or they can verify it as the user requests it. And we're going to show a demo now of one such attribute provider that's being used recently in some demos. So let's say the same user, Bonnie, they came to that website, they logged in, and the website checked and said, oh no, I have no ability to look up any addresses for you. Even though the user had given this website the ability to look at their list of verified street addresses, the website found that there was none. And so that tells the user, hey, you know what, if you want to access your premium content, you're going to go need to verify your address. And it gives examples of a few different ways to do that, using your mobile phone carrier, your cable provider, and we're going to use this ID Data Web attribute provider. Let's say the user clicks that one. They end up on a website, and it's up to the attribute provider to decide what the user experience is. But in this simple one, They're simply asked to enter the street address where they live, city, state, zip code, etc. After they do that, the website says, great, okay, that might be true, but we need to verify it. So what we're going to do is we're going to send a postcard to your house, and when the user eventually receives that postcard, they'll notice there's a verification code on it. They're asked to come back to this website, type in that code, and then when they do so, that address is considered verified and is pushed up to their list of addresses in the cloud. Now this idea of sending a postcard, with this one-time code is actually a quite common technique. You'll see it used, for example, by the Social Security Administration if you want to get your benefits online, or many hospitals use it if you want to request your electronic medical records. Even vendors like Google use it if, for example, if you run a small business and you want to update the hours of the business online in Google Maps for your business entry, well, you need to verify that you own that business. However, in those other examples, the user has to repeat the process for every single website, once for Google, once for each hospital, once for the Social Security Administration, etc. However, in this approach, the user went through this verification process once and then uploaded that street address, verified street address, to their relationship manager, which in this case was Google, but it could have been one of a number of different companies. Now the advantage is the user can go to any website they want to and choose to share that information, and they don't need to repeat this process. They just click, 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 and boom, they're done. So it provides a much better usability. In addition, it's cheaper for these websites. They don't all need to incur the full cost of sending out the postcard or any other verification mechanism. The cost is spread by the attribute provider across the different sites, though it is up to the attribute provider to decide what the billing model is. So, in this case, the user using this ID.web attribute provider just went and verified their address. So now they ask the user for consent to actually add that information, just manage the list of verified street addresses in the user's Google account or whatever cloud-based service they're using. Now, from the end user's perspective, they just need to get the attribute in their cloud provider and then share it to sites. But behind the scenes, a lot more actually happens. We showed how the user ID TV, it would get a list of the user's street addresses, and if it saw them, it could then use one of those to check whether the user was a paying subscriber to that TV channel. However, there's an additional step that happens behind the scenes. The user does give consent for user ID TV or any other website to see their street address, but the site doesn't actually get their address immediately. Instead, it finds out who the user's attribute provider is, goes and contacts the attribute provider with a token that came from the website that got the user's consent to share that information. Now, when the call is made to the attribute provider actually charges a fee to the website, in this case user ID TV, to return that verified information. So this creates an economic model for companies to become attribute providers. And we're already seeing a great amount of interest in this. There have been a number of different industry events to cover this, both for just businesses themselves as well as even government agencies who want to start engaging with citizens online. And so companies like Google and ID.web are already working to bring online pilots using this model, and other identity providers and attribute providers are expected in the future. Now, this is all great, but there's one little potential problem here. If a user gets rid of all of their passwords on the internet and just uses one central relationship manager, and they've now connected that relationship manager to all these different attribute providers for things like street address and name, age, other information, then the question is, well, how did the user log in to that relationship manager, and how do they protect the potentially one password for that account? And this is what the industry refers to as strong authentication, more strongly authenticating users than just a password. Some of you may have noticed that a number of big internet providers like Facebook, Microsoft, Google, etc. are now offering schemes where a user can opt in to having their account protected with something more than a password. For example, they could provide, in this case, Google with their phone number and tell Google, hey, anytime I try to log in on a new computer I've never used before, don't just ask me for my password. Also ask for a one-time code that's either sent via SMS to my phone, or maybe there's an app running on their phone that can generate this code. And so the user to log in has to both type their password and this code. That's designed to protect against schemes like phishing or other situations where the user's password has been leaked, but getting access to one of these one-time codes is much harder. Well, that's great, but we don't see wide-scale adoption of this, and we'd like to see more. We'd like to see more companies trying different techniques to do strong authentication, make it more user-friendly, stronger, etc. And one of the ways we see that this might happen is by providing an economic incentive for companies to provide strong authentication to users. So in some of the early scenarios, we showed how a website like the User ID TV site might actually need to pay to confirm a user's verified address, maybe roughly $2 per user per year. But let's say that same website wants to know that the user was authenticated to their relationship manager, not just with a password, but with something stronger, like one of these one-time password codes. Well, in that case, maybe the website needs to pay more for that information. And for those of you who are even more advanced in security fields, you're probably aware that even these one-time passwords have a potential for some attacks and some form of phishing. So there are more advanced schemes like using a digital certificate associated with a device or a smart card. So a company who can get a user to be authenticated in this scheme might want to charge even more. Take it a step further, we showed how the address verification might be done by sending a postcard to someone's house. But what if there was a vendor who did the verification in person with the user, maybe by seeing their driver's license or passport? All these different things for verifying a user or authenticating a user could be a economic incentive by which companies charge websites for accessing this verified information, and therefore it creates an incentive for them to be a good attribute provider, a good authentication provider. But then one of the questions becomes, great, even if there is the money in this, who is going to perform this job? Who is going to handle authentication for the user? As we noted, some consumer IDPs, Facebook, Google, etc., are making progress getting some users to opt in to strong authentication. But this potential revenue model is now attracting a lot of other companies who may be able to come up with very new and very innovative approaches. One of the common examples that comes up is, what about mobile carriers and smartphones? Could those be used to improve the user authentication? And in fact, there's a specific model that has been suggested that may potentially take off in the future, which is when a user goes and orders a new phone, say online, what they might do during the ordering process is they might give consent to connect their mobile account to their relationship manager account, like a Google, Microsoft, etc. Now in this screen, you'll notice that the user is consenting to let their mobile provider manage their list of street addresses, because the mobile carrier probably already has a verified street address for the user. It's letting the mobile carrier get the user's verified email address, which they generally ask for anyways, and some other basic information about the user's account, like name. But it's also asking the user, hey, can this company help log you into new devices? And what we mean by that is, imagine that Bonnie, who's our user in this scenario, she goes to that flow, gives that consent, orders this new phone, and she takes it out of the box and turns it on. Now, most of us are used to the fact that when you turn the phone on, it knows what its phone number is and immediately can send and receive calls. But behind the scenes, for that to happen, the carrier and the phone needed to communicate with each other to prove that, in fact, that's the phone associated with your account. Well, on top of that, you could actually bootstrap the process of then connecting that phone not just to user's phone number, but also to their online email account, social network account, etc. And the user had given consent for that to happen before. So imagine you simply turn on your phone, it says, "Hi Bonnie, and asks you to unlock the phone the way you traditionally do it, either typing in your PIN or maybe use your finger to draw a code. Whatever it is, the combination of the phone being connected to your mobile account, which is connected to your cloud account, and unlocking it, the combination of the two things, all of a sudden enables the phone to start syncing with your information in the cloud, like your mail, your address book, etc. If you then open the web browser on that device, you'll find you're automatically logged in to your at least primary cloud account that does that synchronization. If you then on that phone go and visit a website like this user ID TV site, or maybe something more advanced like a banking website, well, that website now through this consent flow can, get you logged in, can get your verified address if it needs that, and using the same model as verifying your address, it can also verify how you were authenticated on that device and potentially pay to find out that you were strongly authenticated using the phone network and the same type of technology that's used to bind your phone number to your phone. So this is a very simple user experience for user, this one-time consent linking process, and then you just turn on your phone and unlock it. So there's the potential to combine a simple user experience with some very powerful security in the future, and we hope to drive approaches like this or other new innovative ones using the economic approach that we've described here. So we walked through 4 different things today and just wanted to summarize them again. The first is Account Chooser. You can learn about it at accountchooser.com. And this is designed to drastically simplify the sign-in and sign-up experience for users on the web. The second is this technology OAuth 2 and the related OpenIDConnect that are designed to eliminate password reuse. The concept being you don't have passwords on the vast majority of websites out there. You just have a password on a small number of central services that help you manage your relationships with other websites. The third thing we showed here is how a user might choose to share their verified attributes, such as their street address with the site. There could have been many other attributes. And we talked about the economic incentives for companies to become attribute providers. And then lastly, we talked about the need for strong authentication. If all of a sudden you don't have lots of passwords for all the websites and it's just one password, well, you want to protect that one password so it's something stronger. We talked about how we could do it with one-time passwords as they're being adopted today, and how other schemes might get adopted in the future, such as using your mobile phone. So hopefully this gives you a good idea of where internet identity is likely to head in 2012.